types of fluids we will have. Okay. Okay, so once we are saying that fluids are flowing, so then the study of fluids, study of what do we say? Study of fluids in motion. In motion, study of fluids in motion is called fluid dynamics. What it is? Fluid dynamics. So, under this only we are studying all the concepts like viscosity, surface tension, then Bernoulli principle is there, and types of flow. Okay. So, this is the topic. Okay. Of course, it is floating bodies only, but the fluids, regarding the fluid, because generally what in kinematics, what do we have basically? Suppose mechanics, you know that. So, in mechanics, divided into kinematics, dynamics, and dynamics, dynamics, and statics. So, what is kinematics? Study of objects in motion. Yes or no? Objects in motion. Motion means what again? Relative motion, which are not equal to, that means whose speeds are very less than speed of light. So this I think need not be mentioned. Okay. So that is regarding the branch of mechanics. This is the second branch of so this is one to then this is third one can say. Okay. So dynamics means what? Okay, here study of objects in motion without considering cause of motion. Without considering cause of motion. So this you should not forget. Okay. So, but in dynamics, what do you study? Okay, we study of objects in motion, including cause of motion. This what here cause of motion is force. So force will include force here. And here regarding the equilibrium, study of different types of equilibrium of objects in static equilibrium, dynamic equilibrium, etc., etc., etc. So these are the basic branches what we have in mechanics now. So mechanics is mechanics. Okay, ma. So here in mechanics we have three sub branches once again. That means in physics mostly what we have is okay. So kinematics, dynamics, and statics commonly we say it as mechanics means motion. Okay. So in the first part we are having kinematics, which means what? We study about the objects in motion without considering the cause of motion. Here, force is excluded. Force is not included. Here the force is not included. We study only the motion of the object means what here? We study about this one, rest. What is the concept of rest? What is the concept of motion? Again, motion, types of motion, uniform motion. What is meant by uniform motion? What is meant by non-uniform motion? Then, again, when you come to this, after the concept of motion, what do you study here? You study regarding distance, the concept of distance. Immediately, once you say distance, Then displacement is also there, because here distance is a scalar physical quantity, displacement is a vector physical quantity. So distance and displacement. So once the distance is over, then you go for the speed. Speed means again uniform speed, instantaneous speed, and average speed. So uniform speed, instantaneous speed, and average speed. So you know all the definitions. Briefly I am going. So after speed, then immediately velocity, because here once you say distance and displacement, then comes speed and velocity. Speed and velocity. So how do you define speed? How do you define velocity? What are the definitions? You know already. Okay. So velocity also, once again, you have uniform velocity, you have average velocity, you have instantaneous velocity. So after the types of speeds and velocities, you study acceleration. That's all. Okay. What is the concept of acceleration? Again, in acceleration, what is meant by positive acceleration? What is meant by negative acceleration? And all the terms related to those things. Okay. So positive acceleration plus a, negative acceleration, we call it a retardation, or what is that one? Retardation, deceleration, etc. Okay. So here, whatever you are speaking, there is no discussion regarding force. Yes or no? So you are not mentioning about force anywhere here, but here you will include the force here. Okay. So the reason of this motion, first you discuss here about motion, then the cause of the motion you study here. Means types of force. First of all, what is the concept of force? Types of force. What is the definition of force? Then again Newton's laws. Then again the remaining. That means the concept of inertia, the concept of once again the Newton's second law. What is Newton's second law? Okay. So like again you will get the concept of momentum there, momentum, and finally Newton's third law. Then impulse. What is the meaning of impulse? What are the applications of impulsive forces in our daily life? All those things. And coming to the last one, starting with this, the equilibrium state. When we say that an object is at a equilibrium, means what? Balanced state. That's all. Okay. So balanced state when it is at rest, static equilibrium. Balanced state when it is in motion, dynamic equilibrium. So like that, dynamic means what? In motion. So fluid dynamics here makes what? Finally, the fluid is in motion. Actually, fluid motion is a complex phenomena. Fluid motion, okay, is a complex phenomena. Means what? Complex means it contains many things. To understand the fluid flow of the fluids, okay, it contains many concepts which we have to understand. That is what we discussed yesterday. Okay, a few things we have already discussed yesterday. What are those? What are those? The types of forces what we have discussed. Okay, that are present in the fluids. So briefly, if we have to revise that one, cohesive forces, adhesive forces. Cohesive forces and adhesive forces. So what are the examples of cohesive forces? What are the examples of adhesive forces? So cohesive forces are the forces which exist among the atoms or molecules of a substance or of a fluid among the same kind. That means the forces which exist among the atoms or molecules of same kind is called as cohesive forces, and the forces which exist among the atoms or molecules of different kind are called as adhesive forces. So example of cohesive forces among the molecules of water. If you take water, the attractive forces among the molecules of water. Suppose if you take any oil, the attractive forces among the each and every molecule within that fluid. Okay, similarly gases also we have discussed. Then adhesive forces. Adhesive forces, suppose you are pasting paper on another paper, then plank and another wooden plank, or some other plywood and other normal wood with the help of what? Fevicol, glue, gum, etc. These are all. Okay. So here the force of attraction between the gum molecules and the paper molecules, or the Fevikwik molecules and the wood molecules, or the Fevicol molecules and the plywood molecules. So these are all the adhesive forces. And then we have discussed about viscosity. So in viscosity, we have discussed that when a fluid is flowing, okay, the layers among the fluid, they offer resistance so that the layer which is one above the layer, okay. So if you take one below that means the layer which is present below another layer, the layer which is in the bottom, okay, or below the layer which is in the above part, Okay, this offers a resistance, and this is called as okay viscosity, viscous nature. Okay, viscosity. So here we come to the next topic, that is okay types of what is that one? Types of flow. That means if a fluid, that means whether it can be a gas or a liquid. Okay. So what are the types of flow we have? So after this only we can go for Bernoulli's principle. Okay. To understand Bernoulli's principle, okay, we need to understand how the fluids will flow, or what by flowing, what are the properties they are following. Okay, or what are the properties that are presented when fluid is flowing. Okay, so first if you could understand that one, then you can understand Bernoulli's principle very easily. So for example, so the Bernoulli's principle, application of Bernoulli's principle is okay in the flying of an aeroplane. So flying, the principle behind flying of an aeroplane, okay, is principle behind the okay flying of an aeroplane. Flying of an aeroplane is what is Bernoulli's principle. Bernoulli. Bernoulli's theorem is there, but it's different again. Okay, ma? So to understand this one, first we need to we need to understand types of flow of fluids. So basically we have three types. Okay, one is laminar flow, then turbulent flow, and then finally, what is this one? Laminar flow, turbulent flow, streamlined flow, right? And then finally we have second one is the streamlined flow. Streamlined flow. Streamlined flow. And then finally we can come to the turbulent. Okay, we discuss about this one after that. Then we will come to the Bernoulli's principle. Okay, ma? So then we will go for the surface tension concept. Okay, alright. So here, what is meant by laminar flow? First one, laminar flow. Laminar flow means what is? What is flow? If the velocities okay, the velocities at different points are different in the fluid. The velocities at different points. Different points. The velocities at different points are different. Are different. In a fluid during its flow. During its flow. Such flow is called as laminar flow. Flow is called as laminar flow. Okay, ma'am. Observe this definition. So we can suppose if I draw a diagram here like this. Okay. So in fact, this is the lines representing the flow of the fluid. Okay. See here, I have drawn the lines at different levels. Okay. Here the V, here the V, and here the velocity. Okay. So you can imagine like what we have discussed regarding yesterday's viscosity. Okay. So this process means if a fluid is flowing, suppose in a particular area, that could be a gas or that could be a liquid. Okay, if a fluid is flowing, whether in the open air or whether in an open space or in an enclosed space, means for example like a pipe. Okay, so if a fluid is flowing like this, okay, if the velocities are different, the velocities are different at different points. See, I have taken here point 1, this is point 2, and this is point 3. So, at the different points, the velocities are different. Okay. So I said, okay, V1, V2, V3. So, V1, V1, V2, and V3. Okay. If V1, V2, and V3 have different values. Okay, of the flow is called the laminar flow. V1, V2, and V3 have different values. Okay, values are different. So this we have discussed yesterday. So while a river is flowing, I said that in the topmost layer speed will be maximum, in the middle layer the speed will be comparatively less, and in the bottommost layer the speed will be comparatively still less. Okay. So in the topmost layer the velocity will be more, little less in the middle, little less in the below layer, and little still less in the deepmost or deepest layer, or in the bottommost layer of that particular river or whatever it is flowing. So like that it can happen, it is possible. So here what you have to understand is that situation is possible because we observe that one. We are seeing it. Okay, we are observing it. Already the scientists they have noticed it, and then they did research on that one, and then they have given us the information. That is what we are studying today, whatever it is. So what do you say about laminar flow? If the velocities at different points are different, see this point is important. The velocities at different points are different. This is the case. Okay. So what is different here? The velocities at different points are different in a fluid during its flow. So this is also important. It is not a static fluid, because what did we say here? The fluids in motion. What is our topic here? Fluids in motion. Fluids in motion means the liquids or the fluids which are moving. Okay, so that is a complex phenomenon. So we need to understand many concepts regarding the flow of fluids when they are flowing. So that is what we are studying one by one. What is that? So first one is, this is the laminar flow. If you have understood this one, I will proceed to the next concept. That is what is called as the streamline flow, which is very important one. Okay. So, okay, I love this. Okay, I love this. And the diagram, okay, I will write afterwards. Right. Then, so the diagram related to this, okay, right here in simple manner. Okay. Right. So this is the diagram related to this one. So then coming to what is this is streamline flow. Very important. Of course, this is also important. So streamline flow means what? Okay, ma'am. So next suppose if the see if a fluid is flowing, okay, through a point or an object or something, and if the flow is steady, the path it takes at a different points is called as a streamline flow. Okay, so I have to draw the diagram. Suppose I draw the diagram. Suppose if something, this is a surface. Some surface is there like this. Okay, some surface is like this. Okay. So now a fluid is flowing up and down on this surface, above and below the surface. Okay. So at any point the curve, okay, if I have to discuss about the direction of velocity of this fluid at a particular point, it will be the tangent to the curve. It will be the tangent to the curve in the direction of motion of the fluid. So now suppose you see like this is the meaning of streamline. Streamline curve. Okay, ma? Now suppose if I have to speak about the direction of velocity at different points. Okay, so how will I get that particular direction? So that is nothing but the tangent. That is nothing but the tangent. So in other words, suppose if I draw a curve here like this. See, this is the curve now. So if I need the velocity here, so it is like this. The velocity at this point. And now the velocity, suppose if I need here, it is like this. The velocity. So here the velocity is like this, and here again the velocity is like this. At different points, okay, at a different points, the velocity is nothing but the tangent to that particular curve along the direction of flow of the fluid. This is called as streamline. This is called as streamline. First of all, what should you know? Streamline meaning you have to know. What is meant by streamline? Streamline is nothing but, okay, the direction. Streamline is the path followed or the path of velocity. Okay, or simply if you have to say if okay, the direction of the curve. Okay, here we have a curve. Suppose what is the what is the path of the fluid followed while it is encountering such a surface, means what will you say? It is a curved path. Okay. So, what you have to understand regarding streamline flow is, first thing is, first you need to understand what is a streamline. What is this? What is a streamline means? It is the path joining the direction of velocities in a curve. Okay, the path joining the direction of velocity. See here. So you can make number of points like this. Now see, number of points here like this. So at every point the direction of velocity is different. So you join the direction of, or you join the points. You join the points of different arc where the direction of velocity is at each point. Then you get a curve here. Okay. So this curve is called as a streamline. So once again I am saying, okay, the line or the path or the curve obtained by joining different point or different velocities at different points. Sorry. Okay. The curve obtained by joining velocities at different points. The curve obtained by joining the velocities at different points. See here the velocity is like this, 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 here the velocity is like this. So at whatever the point you are taking, at the whatever the point you are taking. Suppose you see here, the okay, this point I am taking. See here, one part I am taking. So here it is like this. Suppose if you want the velocity at this point, it is like this. If you want the velocity at this point, it is like this. At this point, it is like this. Yes or no? So suppose now this curve you see. So now this is the curve. Okay. So this is the direction of velocity. This is the direction of velocity. This is the direction of velocity. So this point, and this point. Okay, man. So V direction of velocity, direction of velocity. So like that. If we join all the points, we get a curve. The curve is nothing but a kind of line only. So line can be straight line, curved line, Yes or no? Yes. So the curve what we are getting is called as a streamline, and the method of flow. Understand carefully. Okay. This method of flow, what the fluid is following when it is encountering or when it is coming across a surface like this. A surface like this. So if the surface is like this, then it will go. That is different again. If the obstacle is like this, okay, if the obstacle is like this or like this, then the path followed by the fluid is different. That we will discuss in turbulent flow, the next concept. Okay. So you understand. So that means here, what kind of surface is it? Is it a straight surface or a curved surface? Curved surface. The surface is curved. Now you try to remember the surfaces of the face of a car during inertia, or somewhere I have discussed this one. Streamlined. The shapes of the vehicles are streamlined. Okay. Force per unit area. So how much air it is pushing? How much are fluid? Air is a fluid because the substances which flow are called as fluids. So what are they? Liquids and gases. Liquids and gases combinedly we call them as fluids. No doubt in that. Okay. So when these fluids are flowing, or when these fluids while flowing, when they encounter a straightforward surface, okay, or straightforward surface and a curved surface. See, the situation will be different, no? Okay, so these two objects are different. These two objects are different. So when fluid is flowing upon or through a surface like this and through a surface like this, so it encounters the resistance offered. Now you see, the resistance means what? Obstruction, obstacle. Okay, the thing that is trying to stop it. Okay, if something is trying to stop it, we call it as resistance. What is the meaning of resistance? If something is trying to stop the motion of something, okay, that phenomena is called as resistance, we will say. Yes or no? Now suppose the fluid is flowing, we keep some object like this. So there will be a restriction to the flow of the fluid. Restriction to the flow of the fluid. So that restriction is minimum. The restriction is minimum when the surface or when the shape is like this. Is it visible? Right. It is visible. Okay. So when the surface is like this, the restriction is minimum. When the surface is like this, the restriction is maximum. So you can consider this as the front portion of a bus or lorry, and this to the front portion or the shape of an aeroplane. Okay. So you think of the air resistance or the resistance offered by air when these objects are moving in air. Suppose now you can think of when the lorry or bus of this shape, that means the mirrors are flat now. So mirrors are flat, so they encounter more air resistance. So more fuel is spent to overcome the resistance while moving. While moving. So if you have observed the shape of cars, shape of front portion, shape of front portion of cars and aeroplanes. Cars and aeroplanes. So mostly, okay. So it is curved like this, and aeroplane is still like this. Aeroplane is still blunt. Blunt means curved, bent. Okay, ma'am. So this is the shape. Why they are manufacturing like that means to reduce the friction to the minimum. It cannot be made to zero. No doubt it is. Okay. Resistance or friction cannot be made to zero. It can be reduced to a least or the minimum level. What is that? Minimum level only. So for making it to minimum level or for making it to be the least, so what has to be done is the shape of the vehicle should be exactly like this. So that's why you can see the shape of almost all the cars. Almost all the cars is like this only, front portion. So that the speeds which the cars move will be comparatively the bus. Understood? So as the resistance is minimum, so the fuel will be utilized for motion only. Most of the fuel will be utilized for motion only. But to overcome the resistance and the moving, then more fuel is required. Suppose just simply imagine one situation I will tell. Just imagine that you are running and imagine the situation you are running, of course, by tying a big tire, MRF tire of a lorry, suppose. Okay, you are tying a MRF tire, you are tying a rope to the MRF tire, and that rope you are tying to your belly or waist, and then you are running. So, in which case you need more energy? In the second case, means the case where you are tying a rope and then you are tying it to the tire and then you are running. That means what is happening here in both the cases? In both the cases, what is happening? The case where you are simply running without any tying any load or anything, you will run very fast. Means the resistance offered to you is least in that case. Yes or no? Yes or no? Right. So when you tie a rope and then the rope is tied to a MRF tire and then you are running means it is opposing you. It is not making you to move forward. It is not making you to move forward because it is pulling you back. Yes or no? Yes or no? Yes. So in that situation, you need to spend more energy to overcome the resistance force or to overcome the retarding for the force which is opposing you to not to move. Okay, then you have to spend energy. So the same principle here also is applied. Okay, so if the surface is like this, you encounter or you will have to face more restriction due to air friction. But if the shape is blunt like this, then the flow of air will be or the resistance due to air will be lesser. So, and this is the principle what the Olympic runners, international runners, okay, what they even the military training somewhere you will see all these things, okay, running with the help of tying the what is this one rope to your waist and then tying a tire or something, some load or stone also sometimes, okay. So these are suppose you know Usain Bolt, would have heard the name of Usain Bolt. Usain Bolt, the top Olympic runner. Okay, 100 meters. So till last Olympics, he was the only person. Usain Bolt, I think you would have known. Okay, so he won many gold medals in running. So how the people like Usain Bolt have practiced running, they will say the same thing. Okay, these methods they are following because when they are able to run while turning, while having this load behind them. Okay, so when it is not tied, they go very fast. Okay, so they practice like that. So during the Olympics or during the real competition, so they attain huge speeds. They attain huge speeds because as they have practiced that by tying this one, okay, they get the very less time. Okay, so they run very fast. They run very fast. Okay, that is not our topic. So coming to this one. So here this is the meaning or concept of streamlining. Now this is the streamlined shape. What is that? This is the streamlined shape. So this is called as streamlined flow. Okay, understood. So next, turbulent flow. When a fluid is encountering the surface like this, okay, how does the fluid behave? That I will represent in the form of a diagram here. Observe carefully. Now this one I will reduce. Shortcuts. Okay, right. So streamline, I have not written the definition. So I hope that we have understood the concept. Okay, right. So okay, I have this one now. So first of all, okay, right. So first I will write about streamline. Then I will write about the Streamline flow. After streamline and right. What is meant by streamline? So then, the path followed by, okay. During study, the path taken by the fluid during study flow. And this method of flow by fluids is called as streamline flow. Okay. So the method of flow of fluids where they follow streamline is called streamline flow. Okay. Or otherwise, if you have want the standard definition, how can we say it is flow? So streamline flow. Okay, so now you try to understand the standard definition. Okay, so now we have to define the standard definition. So what do we say is, okay, so a curve whose tangent at any point, curve whose tangent at any point, whose tangent at any point is in the direction of flow of the fluid, in the direction of flow of the fluid, in the direction of fluid velocity, direction of fluid velocity. Okay, at that point, in the direction of fluid velocity, okay, diagram I will draw it now. In the direction of fluid velocity. Okay, at that point is called which is called streamline flow. You can understand in any manner. You can learn anything. Both are same. Streamline flow. Okay, man. So if I have to draw the diagram, so here it is like this. Suppose some surface is here like this. And then okay, so this is the curves we have here. These are the curves, and at any point, these are the directions. At any point, these are the directions. So if you have to see at this point, this is the direction of velocity. Velocity direction. So this is called as streamlining. So the example of the daily life. See here, the statements. The path taken by a fluid during the steady flow. See here, the flow is steady only. So suppose the aeroplane is moving means the flow above that means this front portion of that one will be steady only. Yes or no? So that depends on the obstacle of the object. See. So in that situation, you can say that flow of air is steady. Okay, right. So then this method of flow of fluids when they follow streamline, right? When they follow streamline is called streamline. See here, First, you understand the meaning of streamline. What is the meaning of streamline? The path taken by fluid during steady flow is called as streamline. So, when the fluids are following that streamline flow, or when the fluids are following that streamlines, then such flow we call it as streamline flow. And coming to standard definition, the same thing. A curve whose tangent. See, this is the curve. See, this is the curve. Okay. So suppose this is the. See, I am taking this curve. So the tangent. See, for this curve at a point. So at this point you have to take the tangent. So how does it come? It comes like this. It comes like this. This is okay. So this is the curve. So here I want the tangent. So this is the tangent at this point now. Okay. So this is the tangent at that point of that particular curve. So a curve whose tangent at any point is in the direction of fluid velocity. See how the fluid is flowing. This is the direction of fluid velocity. No? So velocity of fluid and the point here at this point also the velocity is the same. See it is like this. So at this point again it is different of course. Okay. Okay, curve whose tangent at any point means here what is the meaning? Suppose if here you will take, suppose this is also a curve. Here the tangent is coming like this. That means the fluid there is flowing like this. See. So finally what you understand? In the front portion the fluid is flowing like this and above see the fluid is flowing like this and then this. Okay? Observe carefully. The fluid is initially it is flowing like this. Suppose there. Okay. So initially flowing like this and again coming like this and again going like this. Sir, are you getting? Okay, are you understanding? So the fluid is first flowing like this, then upward. Okay, this part. Suppose if down part I have to say it is going down and again coming like this and flowing like this. Sir, so overall, so finally what you have to understand is because of this streamline flow, because of the streamline, not only here now. So now see example for this one in air is aeroplane. You see in water also that is a submarine. Okay. The shape of submarine also like this only. So you can imagine. So anyway, whether it is an aeroplane, whether it is a passenger flight or fighter aircraft. Yes or no? Yes. So even the ships also you can see. Ship, what's the shape of the ship? This is like this. Yes or no? The water will be, it is cutting the water and then going. So that means it is reducing the friction while moving in the water. The shape of a ship is not like a lorry or bus, no? Is it flat like this? If it is flat, then most of the fuel will be utilized for overcoming the water resistance only. That too, the sea water or the ocean water, it will be more dense. More dense means more resistance. Yes or no? Yes. So it is not only regarding the aeroplane or what is that fighter or passenger or fighter aircraft we can say, but it is also applicable for the objects that are moving within the water, on the water. Okay, on the water you leave it, inside the water. Because here completely we can say aeroplanes are moving in the layer of our atmosphere only. No, are they going upward? Are they going up to the layer? No. Yes. So I have a question now. So whether you can answer or not, okay, I will tell the same answer, but not now. I will give you time Monday. Okay. By tomorrow, you try to answer. Okay. Right. So, what is my question is? Okay, I got this doubt when I was studying my 10th class. Okay. So, suppose these flights and all, they are all okay. You know that Earth is revolving. Yes, sir. Earth is revolving in a particular direction, and the flights are moving from suppose Delhi to Dubai, Delhi to USA, something. You need to go to Delhi to America. So instead of going here like this, suppose you can make that flight move up little and then come down when that place comes. Why it is not possible? Why they are not doing like this? So anyway the earth is moving only, that you know very well. So instead of going from here to here something like this, okay, you can just go up as the earth is turning. You can again, when the place, suppose you are in Delhi, and in Delhi, the flight can just go up like this, and as the earth is moving, and when America comes, it can come down. Why it is not happening so? I want the answer by tomorrow if it is possible. Now come to this one. Okay. Now here, this is the case. So for a submarine also, the shape is curved only, so that it will encounter the least resistance. It will encounter the least resistance so that it can move fast. It can move fast comparatively, relatively, both are same. Okay, so that is called as stream manifold. Then turbulent flow. So what is turbulent flow is okay. Just I will rub this one the above part. Turbulent flow. Okay, right. Okay, but just first I will draw the diagram, try to analyze, then suppose some obstacle is there like this. Okay, the fluid is flowing towards it. This much not. I will notice the difference. I will notice the difference here. See here. This is see. Some small storm like or small circular, that means the water flow you would have observed. Okay. Such a small circles. Okay. So this is called as turbulent flow. That means during the low speeds only, low speed. So this situation you have seen when you are observing this water which is flowing and a pillar is there. Okay, dams or somewhere. So that water when it is flowing, it will be encircling that surface. It is encircling that particular surface. Okay, and then of course flowing upwards. So it is flowing upwards slightly like this, and there is a pillar here. So when it is, the pillar is like this, straight shape. Okay, like this. So this water when it is encountering this one or coming across this one, here a circular path is formed, and again it is moving in a straight path. Again it is moving forward. Okay, such a flow we call it as turbulent flow. Okay, definition I will discuss tomorrow. I think. Okay, thank you for listening class. I think you have understood up to this part of our discussion. We will meet in the next class. Thank you.